Well, thanks, Peter, and welcome everyone to this slightly cut-down version of our standard corporate presentation. To try and keep this into a 10-minute presentation, I'm just going to focus on some key points. We have a fairly simple objective, and that is to prove that Veyonda, which is our primary drug candidate, is the answer to unlocking the door to the immune system being able to fight cancer. And if we can do that, then it should play a key role in transforming what currently is a $30 billion, that's US dollars, $30 billion US dollar market into what a lot of analysts believe could be a $150 plus billion dollar market. So this is all about immuno-oncology therapy, or IO therapy. This is the big new wave in oncology at the moment. It's and it's generally recognised and acknowledged that this is going to be the future of cancer therapy. This ultimately will replace most chemotherapy and most radiotherapy. The problem with it is that as good as it can be, and when you get a positive response, the responses can be quite dramatic. The problem is that it's only working in about 5% of cancer patients. So only 1 in 20 cancer patients respond to IO therapy. So there's a huge amount of way to go yet. Now, IO therapy involves a whole range of different technologies, and each one of these technologies is aiming to get the immune system back on track to doing its job. But the trouble is that regardless of how you do that, you still end up with a common enormous problem, and that is being able to get those activated immune cells inside a tumour. Tumours are very good at excluding immune cells from them. So activating the immune system is only half the task. The other half is getting that active immune system to then work in tumours. And that's a major problem that's facing just about every other company that's involved in this race to find an effective IO therapy. Veyonda, our drug Veyonda, overcomes this problem, and by so doing, it's making IO therapy potentially accessible to pretty much all cancer patients. So, here in a nutshell is the problem. On the far left-hand side, what you're looking at is any normal tissue. This could be a breast, it could be a lung, brain, it could be anything. And those little red T cells you see, they're the immune cells. And every minute of the day of your life, these little red immune cells are crawling through every tissue. They're inspecting every single cell in your body almost every day or two, looking to see whether it's abnormal, and if it is, remove it. That's called immunosurveillance, going on from the moment you're born to the moment you die. What happens when a cancer emerges, starting with a small number of cells? They make a chemical, and this chemical is key to our whole story. It's a chemical called sphingosine-1 phosphate, which will shorten to S1P, and we'll shorten that even more to CYP. So CYP is a chemical that is required by all cells in order to survive and function. Tumour cells just happen to make bucket loads of it. They make far more than a normal cell will. And so levels of CYP begin to build up in a tumour. And that has the effect of driving out these immune cells. And as the tumour develops and eventually becomes completely all cancer cells, the levels of CYP in that tumour are so high that immune cells are just totally excluded and can't get back in. So it's a case of excluding, throwing out, and then making sure they cannot get back in. That's called a cold tumour. And what we need to do is to restore or to reverse that. And the way you do that is to knock out CYP. You have to stop the tumours making CYP. As soon as you do that, that shield is removed, and the immune cells are now able to come back into the tumour. And these tumours are now referred to as hot tumours. So we're turning a cold tumour into a hot tumour. So this depicts what a cold tumour is and what a hot tumour is. And the problem is that the vast majority of human tumours are cold. And in that one statement lies the major problem facing all companies looking to develop more effective IO therapies. Unless you can convert a cold tumour into a hot tumour, then your drug, your new therapy, is fighting cancer with one arm tied behind its back. Veyonda is the first and only drug that we're aware of that removes the shield, and it blocks CYP production, and it does that in all forms of cancer, and more importantly, only in cancer cells. So this is what distinguishes us, even though we're one of many dozens of companies active in the IO drug development space. What distinguishes us is that we're focusing not on activating the immune system, but on getting the activated cells back into tumours. So the essentials about Veyonda, we are quite confident that we're dealing with a first-in-class inhibitor of CYP. We're switching it off. We're switching cancer cells' ability to make this chemical, turning it off totally. In the laboratory, we're able to show that once you do that, the immune cells then are able to re-enter into human tumours. The drug's been used in over 150 cancer patients over the last few years. We know it's a very well-tolerated drug. This is a safe medication. And more importantly, we've seen clear evidence of an IO effect in a number of late-stage cancers. So we've basically de-risked the two main risk factors for any drug development, which is it safe and is it likely to work? We've got 4 clinical trials currently running or completed. So this is a clinical entity. This is not a theory. This is actually a drug that's in the clinic right now. And we have 4 main programs that I've listed there in the blue: IONIC, DART, Lupin, and NOX COVID. And now, for the sake of brevity, I'm just going to talk about IONIC and Lupin. So the IONIC program is a collaboration with some Sydney hospitals and a large US drug company called Bristol Myers Squibb. Bristol Myers Squibb was one of the first 2 companies to bring an immuno-oncology drug to market. And this is a drug called nivolumab, or more commonly known as Opdivo. Now, last year, Opdivo sales topped $8 billion. And that $8 billion represents almost a third of the total sales of Bristol Myers Squibb, which, as you can see here, it's the 11th largest pharmaceutical company in the world, based on sales and market cap. Now, so Opdivo is out there already, being used widely as an immuno-oncology drug. The problem is that this class of drug, and there's 2 drugs or 3 drugs in this class, is that the tumor numbers of tumours that respond to them is quite limited. So there's about a handful of tumours, among them notably lung and melanoma and bladder and kidney cancer, where you can get a response to these drugs. However, the response rate's not high. It's somewhere between 10% and 30%. So there's still 70 to 90% of patients with these cancers aren't going to respond. The other problem is that there's a lot of cancer types where the response rate is so low that doctors rarely even bother using a drug like Opdivo. So what we're trying to see is whether by converting these cold tumours into hot, that we're going to assist Opdivo to work in more patients, so more patients with lung cancer or bladder cancer and melanoma, as well as in patients who've got all those tumour types, breast, ovarian, pancreatic and so forth, where they don't even bother at the moment to really try to use these drugs. If we can do that, if we can lift sales of Opdivo well above their current level of $8 billion a year, we're confident that would make Veyonda an extremely valuable prize. So this is a study that's about to start. It's going to occur in 3 Sydney hospitals to start with. It gets underway early in the new year. It's a pilot study. We'll start off with 30 patients. It's being organised and run by Professor Paul D'Souza. Paul is one of Australia's most eminent oncologists. He's, in fact, Dean and head of the School of Medicine at University of Wollongong. He held the Foundation Chair in Medical Oncology at Western Sydney University. And he's a private medical oncologist as well. So Paul has put together this study and brought the 2 companies, ourselves and Bristol Myers Squibb, together to collaborate in this study. And we'll be dividing the patients into 2 cohorts. The one half of the 30 patients will have been recently treated with Opdivo but have not responded, so they've now progressed. So we'll be going back in and using the combination of Veyonda and Opdivo to see whether we can now instigate a response in these patients. And the other half of the patients will have tumour types where they would not be considered eligible for Opdivo treatment, but again, we'll be giving them Opdivo and Veyonda in that case. So that's an exciting study that's, as I said, getting underway very shortly. And we'll be reporting on that over the course of the next 18 months to 2 years. You won't have to wait a long time to see whether this is working or not. This is what's called an open label study. We'll be reporting on this every few months. And given that each patient is their own control, that is, they've either failed Opdivo or they would be expected to fail Opdivo. If we can demonstrate any response in those patients, then we're confident that this would put Veyonda well and truly in the global spotlight. The second way I just want to talk about how we're using Veyonda is quite a different way, and this involves using it specifically in men with late-stage prostate cancer. And it involves a drug called, it's a radioactive pharmaceutical called lutetium PSMA 617, which we'll just call Lu-PSMA. It's as I said, a radiopharmaceutical. So it's a drug that's got a radioactive element to it. And this technology, which came out of Germany about 10 years ago, was bought 2 years ago by the big Swiss company Novartis for $6 billion. They acquired it in a $6 billion transaction. Now, that particular drug is at the moment given to men who basically failed all other forms of therapy, and the effect on survival is strong. So the average or the median survival, that is the time at which about half the patients die, moves from about 3.5 months to 13.5 months. So that's significant. Now, St Vincent's Hospital came to us a couple of years ago and said, look, we still think there's an awful lot of scope to improve that even further. Let's look at using Veyonda with Novartis's drug. So they ran a 56-man study, a phase 2 study, which is now fully, the patients have been fully treated. So those men are now just being followed for a year to see how they're going. The first report they made earlier this year on the first 32 men came in and it gave a median overall survival of 17.1 months. So that's 17.1 versus 13.5. So they were highly encouraged by that. And I point out that this is a dose response study, so we're using 3 different doses of Veyonda. And we think the high dose, the 1200 milligram dose, is the best dose. So that data, which includes the 1200 milligram dose, is going to be presented to a conference, big cancer conference in the US in the middle of February. And that data is going to be extremely important in showing just how much value Veyonda has delivered to to this quite promising form of therapy. So this is a very brief summary of the key metrics of the company, and I won't speak to that other than just leave it there for you to look at. And that's the Noxopharm story, which we regard as an eminently exciting and potentially highly commercial opportunity. Thank you.